let's do this and then come back to cards again momentarily. So we're thinking now about a single trial like tossing a coin. And we're going to label the outcomes, the possible outcomes as being 0 or 1. So we'll say that if the coin lands heads, we'll call that 1. If the coin lands tails, we'll call that 0. Or if the coin lands heads, we'll call it success. If the coin lands tails, we'll call it failure. We have two possible outcomes. It's a single trial that can result in two possible things happening. And we're going to define the probability distribution as follows. The chance that of a 1, chance we get heads, is p. The chance we get 0 is 1 minus p. The chance of anything, the chance of heads or tails, is 100%. And the chance that we don't get anything at all, the coin doesn't land, is 0. Okay? Now, this satisfies the axioms of probability, right? P is some number between 0 and 100%. So if p is between 0 and 100%, so is 1 minus p. Right? Okay. So there are only, how many subsets are there of, the outcome space here, S, is equal to 0, 1. Those are the only possible things that can happen. This set has two elements. How many subsets can you make from a set with two elements? If we have a set with n elements, how many subsets can we make from a set of n elements? For each element, we get to decide whether that element is going to be in the subset or not, right? Okay, so there's two possibilities for whether 0 is in the subset. Having put 0 in the subset or not, there's two possibilities for whether 1 is in the subset. Okay, so there's 2 times 2 squared possibilities. Remember when we were talking about the binomial coefficient, combinatorics, we talked about the number of possible subsets of a set with n elements is 2 to the n. Because you have a tree, you get to decide, is the first element in the set, yes, no. If it is the second element in, yes, no, et cetera. And so you end up getting 2 to the n possible elements. So if we have a set with 2 elements, there are 2 to the 2 equals 4 possible subsets. What are they? Well, we can have none of the elements in the subset. We can have one element in the subset. That can happen 2 different ways. Or we can have both elements in the subset. Those are the 4 subsets of this set. Okay? And there are no others. That's it. Right? Okay. So if we want to verify that this distribution, this way of assigning a number to a subset really is a probability distribution, we need to verify that it satisfies the axioms. So does it assign a non-negative number to each one of these things? Yeah, it assigns 0 to that, 1 minus p to that, and 1 to that. All those numbers are positive. Okay? It assigns 1 to that. That's the second axiom. And what's the third axiom? Well, that the chance of the union of any two of these things is the sum of their chances if they're disjoint. Okay, so what are the disjoint possibilities here? Well, that and that are disjoint because the empty set is disjoint from everything. So what's the chance of the union of that and that? Well, the union of the empty set in any set is just the original set. So the chance of this or this is the chance of this, which is 1, which is 0 plus 1. So it satisfies that. Okay? Similarly, the chance of this union any of these is going to be 0 plus the probability of that. It's going to work out. And the only complicated case is this one, where we look at the chance of this union that. Okay? Well, what is the chance of that union that? That union that is this. Yes? The chance of this is 100%. The chance of that is p. The chance of that is 1 minus p. P plus 1 minus p is 1, 100%. So it works out. It satisfies the third axiom as well. So this really is a probability distribution. Okay. Everybody's glazed. All right. So, probability that you get 0 or 1, right? This, what is 0 or 1? it's this. Okay? And what is the probability of 0, 1? Well, it's defined to be 1. Okay? So, and that's in fact probability of 0 plus the probability of 1. Because that's p and that's 1 minus p. They sum to 1.